Hello guys, this is Dr. Maha Abdurrahman again. I'm back after a long pause. I was not able to upload any videos over the last 3 months. I was extremely busy, but I'm back again with the kinetic theory and particulate of matter or properties of matter. And let's begin with the first question. The kinetic theory explains the properties of matter in terms of arrangement and movement of particles, and they're starting with nitrogen as an example of a gas which spread far apart and move in a random manner in a high speed, and they allow us to draw a diagram showing the arrangement of valency electrons in the nitrogen molecule. Nitrogen molecule is N2. As you know, it's a diatomic molecule. Nitrogen is in group 5. That means it has 5 electrons in the outer shell. So let's represent that in the diagram. So nitrogen has 1, 2, 3, 4, 5 electrons in the outer shell. And the other nitrogen, since it's diatomic, will have the same 1, 2, 3, 4, 5 electrons as well in the outer shell. And as you see here, if I want to draw the bonding between the two nitrogen, there is a triple bond here. The reason there's a triple bond, because each nitrogen has 5 electrons in the outer shell, it still needs 3 more to have a complete outer shell of 8 electrons. That's why it has to form 3 bonds with each other. With that being said, those are the 3 bonding electrons, or the 3 bonds that's formed of 6 bonding electrons. So I'm gonna show them like this. So this shows that these 3 or these 6 electrons or the 3 pairs are the triple bond that is bonding the 2 nitrogen atoms together. So this is the 1 molecule of nitrogen. Okay, there's 2 marks for that. Now let's move to the AII. How does the movement and arrangement of the molecules in a crystal of nitrogen is different from those in gaseous nitrogen? So basically they would love you to compare between the solid, because crystal of nitrogen is a solid structure, and the gas structure. Okay, I really love to do that in a comparison way. Now, if I want to talk, or if I want to do it like in a comparison way between solid and gas, okay, so for solid, I would say about the how the particles are arranged in solid. It's arranged in a regular lattice or in a regular structure. So solid, I would say that the particles are arranged in regular lattice or regular structure, right? That's a 1 point. I need here a 3 points because the mark is out of 3. So it's arranged in a regular lattice where particles are very close. Particles are arranged in regular lattice. They're very close, so I can just write, and they are very close together, or packed together, you can say that. And as well, about the movement, they vibrate around their position. Now, regarding the gas, the particles of gas, as we all know, they're arranged in irregular pattern. So particles are arranged in irregular pattern or random pattern, I would say random pattern. And as we all know, the distance is very far, so distance between the particle is far apart. And the last thing that the particles are consistently moving, so they move in a free manner, or they're consistently moving. So that was the comparison. I don't think it's hard. Now let's move to part B. Use the idea of kinetic theory to explain the following. A sealed container contains nitrogen gas. The pressure of the gas is due to the molecules of the gas hitting the wall of the container. Explain why the pressure inside the container increases when the temperature is increased. So you need to relate the movement of the particles hitting the wall of the container to increase the temperature. That's basically what they want you to do, okay? And it has 2 marks, so you need really to, when the question has 2 marks, you really need to have 2 pieces of information. So what would I say? That when I give energy, the particle is gonna move faster. So let me write that down. So providing energy, or heat providing energy, so what will happen, that particles move faster, particles move faster when they get more energy. When they move faster, they will collide harder, with each other, okay? So more collisions, collide harder, and also there will be more collisions between the particles itself and between the particles and the wall of the container, okay? So these collisions will increase the temperature. So this will increase the pressure inside the container. So when those particles collide more frequently, harder, between one another and between the wall of the container, or collide harder with the wall of the container, the pressure basically inside this closed area will be increased. Let me draw that. So this is the container. Now when the particles of the gas is giving heat, when I'm providing heat over there, what happens that they collide more with each other and they collide more with the wall of the container. This collision will make the pressure inside the container, common sense that it will increase. I hope that was clear. And let's move to the other page. Okay, so that's the second question. Back to the diffusion, or continuing on the diffusion. The following apparatus can be used to measure the rate of diffusion of gases. And as you see here, we have been using 3 different gases at 3 different temperatures: nitrogen, chlorine, and nitrogen again, but at higher temperature this time. So this time the nitrogen here is on a higher temperature, and then he's measuring the rate of diffusion at each time. Explain why the nitrogen diffuses faster than the chlorine. Well, if you look at the diffusion here for the chlorine is basically less, and we know that the rate of the diffusion really depends on the molecular mass of the gas. If I check the molecular mass of the chlorine in the periodic table, you will find that it is less than the nitrogen. That's why the chlorine is lighter, so it would diffuse faster. So that's exactly what I'm gonna write. So I would say that the nitrogen, so here the rate of diffusion is more than the chlorine, because simply nitrogen is lighter. So nitrogen is lighter. When I say lighter, I mean that it has smaller, nitrogen has a smaller MR, or smaller molecular mass than the chlorine. Having said and why it's lighter, so by sense, since it is lighter, it will move faster. So that's why nitrogen will move faster, or diffuse faster. I can say diffuse faster. Okay? Explain why the nitrogen diffuses faster at higher temperature. So they basically comparing these two results. Why the nitrogen diffuses faster at higher temperature. Basically, I'm gonna relate to the question that they just answered. When you are increasing the energy for the molecule, they're gonna have more kinetic energy to move. So basically, that's why they will diffuse faster. So I would say that at higher temperature, what will happen is that the molecules gain more energy, so move faster. So gain more energy, that's why they move faster. That's it. That's an easy one, easy question. Let's move to the other question. This is a heating cooling curve, and as you see here, as I increase the as the time goes, it's relating the process of the reaction to the temperature. Okay, so basically here this is a heating cooling curve. Now, what happens by time where you are heating the compound, because that's a heating curve. So you're basically giving some heat for the compound that you have, and then you check how it's moving from solid to liquid to gas. So in X, or is X a solid, a liquid, or a gas at room temperature? From the way how the curve it is, it's moving up like the temperature, and then there's a stability over B to C. This stability is due to melting. Okay, so that is the melting point basically, and then it goes up. Now here all the particles are liquid, so any heat is given to those particles is going to be used to raise the temperature. Then there will be a moment where the temperature will stay the same. This moment basically is the boiling point. So this is the boiling point. After the boiling point, after all the liquid particles been changed to gas, the temperature of the molecule will increase again. So by this quick analysis, this gives you that solid or particle X or substance X is a solid. Okay, but no, sorry, they're asking you at room temperature. Is it solid, liquid, or gas at room temperature? So I need to check where the room temperature lies on this graph. So if you check here, this is 15. Well, 15 is the melting point. That means this substance will be liquid at 15. Having said that, if I move up to 20, at 20 the substance X should be liquid. Okay, so it should be liquid at room temperature, which is 20, because the melting point is 15. Makes sense? And okay, and then write an equation for equilibrium which exists in region BC. So basically in region BC, my solid is turned to liquid, right? Okay, so with that being said, I would say my substance X in the solid state is gonna change to substance X in liquid state. And because they mentioned equilibrium, so I need to write the two arrows, because basically at BC there's still an equilibrium between solid and liquid until after BC, like in CD, as you see, it's all now liquid. But still in BC there is an equilibrium. That's why you need to draw the two arrows. Name the change of the state which occurs in region DE. DE basically is the boiling point. Boiling point. Okay. And then explain how the curve shows the pure shows that a pure sample of compound X was used. Explain how the curve shows that this is a pure particle. Okay. Now, since the melting and the boiling was at fixed temperature, not over a range of temperature, this tells me that my substance is pure. Why? If the substance was not pure, you will find that it melts and boils over a range of temperature because there are more than one substance. But since it's a single pure substance, you will find that the melting point and the boiling point is at single sharp specific temperature. So that's what I'm gonna write. I would say that in the melting, because the melting point and the boiling point is at one fixed or specific temperature. So this what shows me that this sample is pure. Okay, I hope it was easy and clear. Now let's move to this question. And that will be the last question. I got this question from the chapter bonding, and this is a 6 marks question which require some detailed answer. I'm gonna go over that with you to show you how to acquire the 6 marks. Now, it's not only has to be a detailed answer, it has also to be coherent, explanation is clear, your statements are linked together in a logical sequence. Let's go over to know how to solve those parts of or those type of questions of 6 mark questions. First of all, let's read the question carefully. So if you look, you're gonna be assessed for good English organizing information. Okay. Explain why chlorine gas is a gas at room temperature. Why is it a gas at room temperature while sodium chloride is a solid at room temperature? So that's basically the main question. They kind of guided you here by drawing the molecule of chlorine. Obviously, this is a covalent molecule. To be more specific, it's a simple covalent molecule. Sodium chloride, from what they have drew and from our information, is a giant ionic compound. So include a description of the bonding structure of the chlorine and sodium chloride in your answer. So I would say the key for this answer is to recognize that the chlorine gas is a simple covalent molecule, the sodium chloride is a giant ionic compound. Then we're gonna go from there. So let's start by the chlorine. Why is it gas? Basically, I'm going to start that chlorine gas, as we said, is a simple covalent molecule, okay? Now, between the simple covalent molecules, between each molecule and the other molecule, there is weak intermolecular forces. So it's a simple covalent molecule with weak intermolecular forces, right? Don't write between atoms, between molecules. Why? And I'm stressing on this, it's between molecules. Why between molecules, not between atoms? Because basically between the atoms there is a covalent bond. Can you see here? And the covalent bond is very strong. I wanna write that in my answer as well. So weak intermolecular force between the molecules, unlike the strong covalent bond between the atoms. So, so this is just for you to realize the difference. So having this weak intermolecular forces, a weak attraction between molecules, this will make us require less energy or very low energy, right, to separate the molecules, right? Because already the bond between the molecules are weak, which is the weak intermolecular forces, so less energy to separate the molecules. So that's why this molecule or this chlorine gas will have low boiling point. And having low boiling point, this explains why it is a gas. So this is why chlorine is gas. That's it. Okay? If you answer in a proper way, you would get 3 marks for this part. And then let's move to the, I'm gonna change the color. So let's move to the sodium chloride. Sodium chloride, as we said, it is a giant ionic compound. Giant ionic compound with, we need to elaborate more on that because it's a 6 marks question. So I would say with ionic bonding or strong electrostatic attraction. So the ionic bond is basically a strong electrostatic attraction between the positive ion and the negative ion. So strong electrostatic attraction between positive ion and negative ion. Positive ion and negative ion. Okay, so this in turn will require too much energy. So basically it's the opposite to my argument up. So require too much energy to separate them apart. Separate the ions apart. So consequently, they will have a high melting point. So consequently, they would have a high melting point, and having high melting point is the reason why. So this is why sodium chloride is solid. And if you write it in this proper, coherent, logical sequence, again, you would get the 3 marks. I hope that you realize the sequence I'm moving on. So having said it's a giant ionic compound, because there is an ionic bond, strong electrostatic attraction between the 2 ions, the positive and the negative ion. This will require high energy to break them, or to separate those ions apart, consequently high melting point. So that is why this is a solid. And the reverse argument for the chlorine. This is how we approach the 6 marks question. I hope the tutorial was beneficial for everyone, and please subscribe and follow up my channel for more videos in the future. Thank you so much for listening, and see you next time. Bye.